What does the future hold for time travel? What technologies will allow us to take that dramatic leap? We will address those topics and more in our analysis of the future of time travel. Stay tuned for more details. What if you could leap forward in time to see the consequences of your actions today? Imagine the possibilities. Time travel, a concept that has captivated human imagination for centuries, from ancient myths to modern science fiction. Historically, the idea of traversing time has been seen as conceptual within the realm of dreams and imagination. Yet it has remained a constant thread in our cultural fabric, from the mythical stories of gods and heroes who could manipulate time, to the scientific speculations of the late 19th and early 20th centuries. In recent times, the fascination with time travel has only intensified. It's become a staple of popular culture and literature, permeating every corner of our collective consciousness. This fascination, as enduring as time itself, has driven us to question, to ponder, and to dream. Let's delve into the exciting world of future time travel technology. Time travel, a concept once limited to the realm of science fiction, is now being seriously studied by scientists. Our understanding of time travel begins with a man named Albert Einstein. In the early 20th century, he proposed the theory of relativity, which fundamentally changed our understanding of space and time. According to this theory, space and time are interwoven into a single continuum known as space-time. And here's the kicker: space-time can be warped and twisted by the mass and energy within it. This leads us to the fascinating and mind-bending concept of wormholes. Imagine folding a piece of paper in half, then poking a hole through both ends. That shortcut between the 2 points? That's a wormhole. In the context of the universe, wormholes could theoretically provide shortcuts for long journeys across the cosmos, and crucially, for our discussion, potentially even across time itself. Now, it's important to note that while wormholes are theoretically possible based on the equations of the theory of relativity, they've never been observed. And there's a good reason for this. Wormholes, if they exist, are likely to be microscopic and highly unstable. They would require some form of exotic matter with negative energy density to keep them open. But let's not get lost in the quagmire of quantum physics just yet. The takeaway is this: the laws of physics, as we currently understand them, do not rule out the possibility of time travel. It might sound like something out of a science fiction novel, but remember, so were man-made satellites and space travel not too long ago. The theories are there, the math checks out, and the possibility is tantalizing. Time travel, in theory, could be within our grasp, but it's one thing to scribble equations on a chalkboard and quite another to build a machine that can actually move through time. Many scientists believe that the most promising future time travel technology will originate from the study of quantum physics, and more specifically, quantum entanglement. Quantum entanglement is a phenomenon in quantum physics where two or more particles become connected in such a way that the state of one particle is directly related to the state of the other, regardless of the distance between them. This means that the state of one particle cannot be described independently of the state of the other, even if they are separated by large distances. Changes in the state of one particle will instantly affect the state of the other, a phenomenon famously referred to by Einstein as spooky action at a distance. Entangled particles seem to share a mysterious connection that transcends classical concepts of space and time. This principle lends itself to a future time travel technology involving teleportation, where an object, or individual, will instantly move from one location to another, much in the same way the teleporter process worked in the Star Trek series and movies. But translating these theories into practical technology is where the real challenge begins. The road to creating a working time machine is fraught with challenges, both technological and ethical. Let's start with the technological hurdles. Time travel, as we understand it today, would require a colossal amount of energy. We're not just talking about the power it takes to light up a city for a day or even a year. We're talking about the kind of energy produced by a star. In fact, some theories suggest that to open a portal through time, you'd need to harness the power of a black hole. Now, that's not exactly something you can plug into a wall socket. Then there's the issue of stability. Even if we could create a time portal, it would need to be stable enough to allow safe passage through. It's like trying to walk on a tightrope in the middle of a hurricane. The slightest imbalance could lead to catastrophic results. Plus, there's the question of direction. How do we ensure that the time traveler ends up in the right place at the right time? Moving on to the hardware, the machine itself would need to be capable of withstanding the extreme conditions involved in time travel. We're talking about forces and energies that are beyond anything we've encountered in our day-to-day lives. The materials and engineering required for such a device are currently beyond our reach. Now let's shift gears and talk about the ethical challenges. The potential for altering history is a significant concern. What if a time traveler changes something in the past that results in a drastically different present? It's the classic butterfly effect conundrum. The slightest alteration could set off a chain of events that reshape history. And once history is altered, there's no guarantee we could fix it. There's also the issue of responsibility and control. Who gets to decide who travels in time and for what purpose? The power to alter history should not be taken lightly. It could be used for good, certainly, but it could also be used for ill. It's a Pandora's box that once opened, can't be closed again. Lastly, there's the question of the time traveler themselves. What are the psychological implications of time travel? How would a person cope with the knowledge of the past or the future? It's a heavy burden to bear. And what about the physical effects? We know that space travel has significant impacts on the human body. It's reasonable to assume that time travel would have its own set of physical challenges. Overcoming these challenges will require unprecedented advancements in science and technology, and not just that, but also a deep and thoughtful consideration of the ethical implications. It's a long and winding road, but who knows? Maybe the future holds the answers we seek. But for now, the concept of time travel remains firmly in the realm of science fiction. Despite these challenges, scientists and engineers are making strides towards realizing the dream of time travel. In the shadowy corridors of science and technology, the quest for time travel has stimulated an exploration into the realm of space-time manipulation and quantum physics. The theories and principles behind these concepts might seem like they're straight out of a science fiction novel, but they're more real than you might think. Let's dive into the world of space-time manipulation first. The theory of relativity, introduced by Albert Einstein, postulates that the fabric of space and time is not a flat plane, but can be distorted by mass and energy. This has led to the possibility of creating wormholes, shortcuts through space and time. The concept, while still theoretical, is being actively researched, and recent advancements in our understanding of black holes and gravitational waves are bringing us closer to turning this science fiction trope into science fact. Now let's move on to quantum physics, another fascinating field that could potentially unlock the doors to time travel. Quantum physics deals with particles at the atomic and subatomic levels where the rules of classical physics no longer apply. It's a world where particles can exist in multiple states at once, and can even influence each other instantaneously over vast distances. These quantum phenomena could potentially be harnessed to achieve time travel on a microscopic scale. Scientists around the globe are conducting groundbreaking experiments in quantum teleportation and quantum computing, inching us closer to this once unimaginable feat. But with every stride forward, we encounter new questions and complexities. The future of time travel technology is a dense web of theories, equations, and enigmatic quantum phenomena. It's a journey that is as fascinating as it is challenging. The future of time travel technology is promising, and we may be closer to it than we think. So, buckle up, and let's journey together into the future of the final frontier, time itself. Imagine a world where time travel is a reality. What would it mean for us as a society? Let's delve into this mind-bending concept. In a world where time travel is possible, our understanding of history could be completely upended. Currently, history is a one-way street. Events happen, they're recorded, and we look back at them from our present perspective. But with time travel, history becomes a living, malleable entity. Imagine being able to witness firsthand the signing of the Declaration of Independence or the moment the first humans set foot on the moon. Our understanding of these events would no longer be based on accounts and records but on direct, personal observation. But this raises a new set of questions. What happens to the concept of causality? If we can go back in time, can we change events? And if we change something, does that create a new timeline or does it alter our existing one? Here we stumble upon the classic paradox of time travel. If you went back in time and changed something that prevented your birth, would you then cease to exist in the present? These questions challenge the very fabric of our understanding of time and reality. And then there's the question of human nature. If we had the ability to travel through time, how would we use it? Would we use it for the betterment of humanity, to correct past mistakes and prevent future disasters? Or would it be used for personal gain or even to cause harm? The potential for misuse is alarming. Time travel could become a tool for manipulation, a weapon in the wrong hands. Yet time travel could also bring immense benefits. It could be used for historical research, providing a level of detail and accuracy that's simply not possible with traditional methods. Imagine being able to observe dinosaurs in their natural habitat, or to witness the construction of the pyramids. We could gain insights into our past that could help us understand our present and shape our future. Moreover, time travel could revolutionize the field of medicine. We could observe the progression of diseases over time, identify patterns, and develop more effective treatments. We could even potentially prevent diseases before they occur. But these benefits could come at a cost. The ability to change the past could lead to a world where nothing is certain, where history is constantly in flux. This could have profound psychological implications, creating a society that's always looking backward, always second-guessing. The implications of time travel are far-reaching and profound, and they force us to rethink our understanding of time and reality. As we stand on the brink of this new era, it's clear that time travel isn't just about technology. It's about us, about our capacity for curiosity, for exploration, and for responsibility. It's a mirror that reflects our deepest hopes and fears, our greatest achievements, and our most troubling dilemmas. The question is, are we ready to face what we see? The future of time travel technology is not a question of if, but when. We have journeyed through the enigma of time travel, delved into the scientific principles that could make it possible, and grappled with the formidable challenges that stand in our way. We have gazed into a future where time travel technology could reshape our world in ways we can barely imagine. This is no longer the realm of science fiction, but a tangible destination on the horizon of human achievement. We may be decades away, or the breakthrough could come in the blink of an eye. The pace of technological advancement is unpredictable, but relentless. As we stand on the edge of this thrilling precipice, we can almost feel the winds of time whipping past us. The future is not a distant mirage, but a rapidly approaching reality. And remember this, as we stand on the brink of this exciting frontier, one thing is clear: the future is coming, and it's coming fast. Time travel, once a concept of fiction and fantasy, stands as the final frontier for humanity to conquer. This idea, once penned in the pages of science fiction novels, has traversed the realm of fantasy and stands on the precipice of reality. A journey that began as an abstract concept, a mere figment of our imagination, has evolved into a scientific pursuit. We've delved into the enigma of time travel, unraveled the science behind it, faced the challenges head-on, and even dared to envision its future. It's been a journey of discovery, riddled with complexities and fascinating revelations. As we stand at the threshold of this final frontier, we reflect on the implications of such a technology. Time travel could revolutionize our understanding of the universe and our place in it. It could redefine our perception of time and space. It could offer us a glimpse into the past and a peek into the future. The potential consequences, both positive and negative, are monumental. On one hand, we could unlock the secrets of history, witness events from different eras, and even foresee future occurrences. On the other hand, we could inadvertently disrupt the space-time continuum, alter historical events, or create paradoxes that challenge our understanding of reality. Such is the nature of this final frontier. It's a realm of endless possibilities and infinite complexities. It's a domain that demands our utmost caution, yet fuels our insatiable curiosity. It's a horizon that beckons us with the promise of discovery, yet warns us of the perils that lie beyond. As we continue to push the boundaries of science and technology, we inch ever closer to turning this dream into reality. We stand on the brink of a new era, where the once impossible becomes possible, where the line between science and fiction blurs. As we venture into this final frontier, we carry with us the hopes and fears of our species, our collective dreams and nightmares. Only time will tell what the future holds. Thank you for joining Time Pilgrimage on this adventure. And as always, don't forget to like, comment, and subscribe to our channel for more captivating time and space-related content.